John Ray Libardo, PCP2ML. This is my online activity 9 in physics. Different forms of energy. Electrical energy, radiant energy, thermal energy, sound energy, chemical energy, and nuclear energy. Electrical energy. Electrical energy refers to the energy created through the flow of power in the conductor. It is simply defined as electricity. Electric energy is commonly regarded to a secondary energy since it is obtained with the help of primary sources of energy. These are the examples of electrical energy. Next is radiant energy. Radiant energy, that is transmitted in the form of electromagnetic radiation, energy that exists in the absence of matter. These are the examples. Next is the thermal energy. Thermal energy is a term used in physics which refers to the energy created after the potential and kinetic energy of an object in motion is put together. When this energy is applied to a specific substance, the velocity of the particles that make up the substance rises, making it warmer. These are the examples. Sound energy. Sound energy is the energy produced by sound vibration. Sound vibration causes waves of pressure. These waves lead to some level of compression and refraction, through which the waves travel. So sound energy is a form of mechanical energy. These are the examples. Chemical energy. The definition of chemical energy would be the potential energy that can be associated to the structural arrangement of the molecules and atoms. This is an effect of chemical bonds created between the molecules. It should be also noted that chemical energy can be changed into other forms of chemical energy. These are the examples of chemical energy. Nuclear energy. The energy released during nuclear fission or fusion, especially when used to generate electricity. These are the examples. Next is the source of energy. There are two kinds of source of energy: the renewable energy and the non-renewable energy. Renewable energy. Renewable energy is generally defined as energy that comes from resources which are naturally replenished on a human time scale: sunlight, wind, rain, tides, waves, and geothermal heat. These are the examples. Non-renewable energy. Non-renewable resource, also known as a finite resource, is a resource that does not renew itself at sufficient rate for sustainable economic extraction in meaningful human time frame. An example is carbon-based, originally derived fuel. The original organic material, with the aid of heat and pressure, becomes a fuel as oil or gas. Fossil fuels such as coal, petroleum, and natural gas, and certain aquifers are all non-renewable resources. These are the examples. The renewable energy would help to decrease our electric bill. Renewable energy would help to decrease our electric bill with the use of solar power that comes from sunlight. You see in the picture that the sunlight, with the use of sunlight, our electric bill will decrease with the use of solar power or solar panel. Law of conservation energy. Law of conservation of energy, the first law of thermodynamics, the fundamental principle of physics that the total energy of an isolated system is constant despite internal changes. Video related to the law of conservation.
Hi, it's Mr. Schnell here. I just wanted to do a little quick demonstration about the conservation of energy and that law. What I have here is just some water in 3 different glasses. These 2 are empty right now. This first one, you can see it's kind of an upside down looking cup. It's kind of a bizarre thing. But I used it as my potential energy starting point. Okay, so I've got the water inside this cup is representing the total energy in my system. So my system consists of these 3 cups. So this water, which is my total energy, right now is contained in the potential energy cup. And I use this cup just because, it would be pretty easy for it to potentially fall over. So that's kind of the idea with potential energy, that it can easily fall or, be let loose of a shelf or something like that. So this is my energy. Right now it's all stored into potential energy. And if I transfer this energy, I can't make more water. I can't make this water disappear. All I can do is move it from one place to another. Whether I move it into one of these cups, onto the countertop or the floor or into my mouth, the water is still there. I'm just moving it. And so right now if I transfer my energy into kinetic energy, now my total water stayed the same. I only have this much water in my system. This is my total energy. So now all of my energy has been transferred into kinetic energy, which, by the way, is the energy of motion. And so if this water is moving around, it has kinetic energy. Now, I have this other cup with the same label of potential energy on it. Now, the reason I have another cup is that there are multiple forms of potential energy. This one, I was kind of insinuating the idea that this was gravitational potential energy. So it had the potential to fall based on its height or its position. And so what this one could represent possibly is elastic potential energy. So the energy stored in a spring or a rubber band or something squishy like a ball or something like that. It could also be represented as chemical potential energy. So maybe the energy stored in a battery. So now with this kinetic energy, I can transfer. Remember, I can't destroy it. I can't make more of it. I still have the same amount of energy here. All I do is transfer it from one place to another. So maybe I'm going to take this moving kinetic energy and put it into my, let's call it a rubber band. So I took some motion and I stretched my rubber band. Okay, so now all of my kinetic energy is in a rubber band. Now it's potential energy again. And I can take that rubber band and I can let it go. And it's transferred again into kinetic energy. And maybe that kinetic energy made the rubber band go higher in position. So my rubber band has a higher height. At the top of its height, it has potential energy. But somewhere in between, it has both. A little bit of potential energy and a little bit of kinetic energy. It's still moving, but now it has a higher height. And so now we can see how this idea of total energy is conserved within the system. There's always a... And maybe that kinetic energy made the rubber band go higher in position. So my rubber band has a higher height. At the top of its height, it has potential energy. But somewhere in between, it has both. A little bit of potential energy and a little bit of kinetic energy. It's still moving, but now it has a higher height. And so now we can see how this idea of total energy is conserved within the system. There's always the same amount of energy, it's always the same amount of water. Sometimes it's potential as it goes higher up. Now it's all up there, and my kinetic energy is at zero. And so this is the idea of the conservation of energy. Now one thing you might have noticed is that even when it was being transferred from one thing to another, there's always a few drops of energy left over. Okay, sometimes in this case it's spilled on the countertop, or it's just left over as drops. That is something that we're going to look into a little bit further on in the course, and that's the idea of efficiency. Every time there's a transfer of energy from potential to kinetic, or maybe from a gravitational potential to a spring potential, there's always some of this leftover energy. And what happens, that's the idea of efficiency, and the fact that we lose energy every time it's transferred. Usually as heat, sometimes as light or sound, something like that, something that's not usable. And so this idea of efficiency is something we're going to be talking about later. But needless to say, the energy in a system is always constant. Even in the losses of inefficiency, the water is still here. I can still see the water here. I just can't use it just because it's not in my cup anymore. So that's the idea of the law of conservation of energy.
Thank you for watching.